Good afternoon, everybody. Just testing online versus online. Can you hear me? And can you see the screen? Well, I know you can see the screen.
Yes, sir. Yes, sir.
All right, beautiful, beautiful.
Yes, sir. Yes, sir.
All right, beautiful. All right, so persons in the classroom, you know, I'm online. Right, there are persons joining on Zoom. I know that noise in the classroom is a disservice to the persons online. All right, so let's make this a quiet exercise, please. You really want to be grading yourself. I'm going to work out the papers now, work out this paper now. And you're going to be grading yourself. Pass mark, as you know, for today, what did I say, 80%? All right, the pass mark for today is 80% on this paper. So tomorrow, moving up, moving up the pass mark tomorrow. We're doing the same exercise again tomorrow. So the two papers today, the pass mark is 80%. Tomorrow, we'll move it up to 85%. And then papers that we will do in the week, because we're gonna be doing papers Wednesday and Thursday as well, as you know. Those papers, they're gonna be at 90%. And next weekend, we're gonna repeat in the same thing. All day Saturday, all day Sunday. All right? And that will take us into the exam the following week, Friday. Because I know that I will not have a number of you during the week of the exam, because you have other exams. Anybody here have other exams during the week of the exam? Like the Monday and the Tuesday, right? So I know that you'll have to be focusing on those exams. So, you know, let us clear as much as the work as possible before your first exam starts. So I want to clear maybe about 10 papers or so before that exam. So 4 this weekend, maybe another 2 in the week, and then 4 next weekend. That's 10 papers. A lot of these papers you have gone through before. So you have gone through some of these questions before. So it should be an easy exercise for a lot of you. I know some of them you would not have done, because when I gave these papers on the weekends, like you're supposed to do 2, a lot of you only did 1. So this is an opportunity now for you to catch up on the one that you did not do. The more papers you do, the better you understand the structure of the exam. The more you discover your mistakes, find out the things that you're not so good at, and get the opportunity to close those gaps, increase your chance of doing well in the exam. All right, that's what it's all about. So as I said, pass mark is 80%. So as I work through the questions, you grade yourself. All right, you grade yourself. The mark is on the paper. Grade yourself. So let's go. First question. Always is that calculator question. Some fraction thing. Here it is. It says use a calculator or otherwise to get the exact value of this thing. So as usual, I always say, just type this in the calculator up here. Make sure you type it exactly as it is. And that's why we need to get one of those textbook display calculators. All right. If you were doing it step by step, you would have to do this multiplication part first. Find out what that value is before you go and subtract. Right? Because you have to follow the proper order of operation. But I'm just going to put it in the calculator, assuming that you all have one of those calculators. If you don't, you need to get one of those calculators that you can type this in and see it exactly as it appears here now on the screen. All right, and we are subtracting another mixed number. Stop the talking, please. Don't want to start the talking. And I'm getting 0.15 exact. So exact value, I'm getting 0.15. But the calculator can also show it as a fraction, which will be 20. 3/20. That's the answer. 2 marks. So you have to a good start. 2 marks. Next question is this one. Again, we're going to put that in the calculator. So always make sure you clear the calculator before you start another operation in the calculator. So that now is a fraction. On the numerator, we have 4.1 subtract 1.25 squared. And we're putting all of that. Yes?
I put in my calculator, sir, and I got a different answer than 1/20, sir.
Well, you're not
It'd be 3/20, not 1/20.
3 over 20.
3 over 20.
3 over 20 or 0.15. So if you don't get that, it means that your calculator, you need to get a better calculator that you can type this in exactly as it appears
Sir,
there.
I have a
Addition.
question. I have a question.
Yeah.
Sir, if them say exact value, right? If they say exact value,
Yeah, go ahead.
wouldn't it be the fraction more exact because decimal isn't really you know?
No, this one is exact this time. Often you get a decimal that is ending. You do the fraction. This one says exact. All right now, so that is good. But because they gave you a fraction, I think the safe thing to do is give them back a fraction. All right? So that is it. And 6, you don't want to take off marks, you know. So they don't want to take off marks if you give that. But they said if you get a lengthy decimal, non-ending that you cannot write all the figures on it, then put it in the fraction form. All right? Put it in the fraction form. Oh, no, let's finish this one. So again, if you need to calculate that you can type this in exactly as it appears there. If you send me a WhatsApp on my number, I will send you a picture or the type of calculator that you need to get. All right? I'll send you that information, but you can do that afterwards. So I need to put 0.005 under here, and I'm getting 507.5. Just check and same thing I type there. Just check that and make sure. In this case, it is. And so I can confidently write 507.5. And that's another 2 marks. Yes? This is an exact, like this one. They give it, though it's an exact answer. Fraction. The fraction for that one is 1015 over 2. Yes?
I got 508. Is that all right? Or do I need a 507?
No, this is the correct, this is the exact 507 exact. See, they put cap letters, everything important. That means that they want the exact.
Okay, thank you, sir.
The exact answer they want. So 508 is not 507.5. All right, let's continue. All right, this question now says, it says, a stadium currently has seating capacity for 15,400 seats. All right. It says, calculate the number of people in the stadium when 75% of the seats are occupied. So basically that's 75% of this number. That's all that it is. So we're doing 75% times the number of seats. Put that again in the calculator. You can put 75% times the number of seats, 15,400. That gives you 11,550 seats. And it's asking you for the number of seats. People, all right. All right. We're going to write the word people here. So you get stay with a new seating capacity of this. So they're increasing the seating capacity from this 15,400 to this. So let's write it down here. So it's 15,400 being increased to this number. It says after the stadium, after the renovation, what will be the percentage increase in the number of seats? So the percentage increase is going to be the increase of the original amount, the increase on the original amount expressed as a percentage. So we're looking really at the increase divided by the original amount multiplied by 100. What is the increase? The increase is just the difference between these two numbers. I don't have to work with the value of the increase. I just need to show the proper calculation. So it's the original number of 27, no, the final number 2790 minus original number of 15,400. This calculation is the increase divided by the original amount that was there. It's an increase on the original amount. So the original amount is 15,400. And to express that as a percentage, you multiply this now by 100. That is your calculation. I don't need to work this out and show the absolute increase value. I'm not getting any mark for that. So let's put this in the calculator again, a fraction. It's 2790 minus 15,400 divided by the original 15,400. Multiply that by 100 to get it as a percentage, and it's 35%. 35% increase is the answer. Another 2 marks. So keep adding your marks as you go. All right. All right. Let's move on. Question? Huh?
I got 35.06.
35.06.
Yes, sir.
I don't know you get 35.06.
Work
Because
out the sometimes
that
for the
number, you should not get
calculators.
35.06.
Sir, sometimes for the calculators, I got that too, but like when you do the whole thing, you put everything in the calculator at once, it's going to show you that. So you got to work out step by step. So the 20, whatever the numerator, work that out, and then you put that over the denominator and you multiply.
All right, let's see. If I work it out separately and put 20790 minus 15,400, I'm gonna get 5390 is my increase. Put 5390 over the original 15,400, and I multiply that by 100%. Let's see. I'm sure I'm gonna get the same 35%. So if I go step by step like that and put it as a fraction, you guys need to check out your calculator. That's 5390. Put that over the original 15,400 and multiply that by 100. I get the exact same 35%. So you guys will get in different answers with the calculator. You need to check out the calculators. Another thing you need to do with the calculator is that after you do a calculation up here, you need to make sure that you clear your calculator. Press the clear button on your calculator. Clear out everything out your calculator. Because what it might be is that you are continuing on a calculation. I don't know. But I'm just telling you that. Clear out your calculators. After you finish this one, clear your calculator before you start this one down here. You see, the exact answer is 35%. So if you're getting another answer, you're doing something wrong, you're making a mistake, you're changing a digit in the calculator, something. But this is the precise answer. All right?
Sure.
Yes.
Quick question. I don't want to just go back to the other question, but the one with the 4.1 minus 1.25 squared. Since I got 508 and it's not the exact value was supposed to be 507.5. That would just be a 1 mark then. Want to get the 2 marks? So just
Answer that, and you're not gonna get the mark. Look here now.
Oh.
It's simple. Because that's the exact, just get the exact answer. All right.
Oh,
and
so it's completely wrong then. So the 508 completely wrong.
If it's wrong, it's wrong. You can't assume that they're gonna be the mark.
All right, so I just thanks. Never here.
All right, let's continue. All right, this one says, a neon light flashes 5 times. That's 5, the number 5. 5 times every 10 seconds. All right. Show that the light flashes this number of times, 43,200 in 1 day. This can be done in multiple ways. You can find how many 10 seconds are in 1 day, or you can treat this like a ratio, which I believe is the simplest way to do it. Treat this like a ratio, 5 to 10. 5 to 10 ratio, and this is 10 seconds. And increase your number of seconds, increase the ratio to bring the number of seconds up to 1 day. Let's do it that way. Do it like a ratio. All right, so let's set it up this way. So it's 5 times 10 seconds. So I'm going to take that 10 seconds up to 1 minute first. Now, 1 minute is 60 seconds. To get this 10 to become 60, I need to multiply it by 6. So I'm initially just going to multiply it by 6. Remember, the beauty about doing ratio questions is that all you need to do is multiply and divide by values or unit of measure to get what you want to know. That's all you need to do with ratio questions. So I'm going to do it like a ratio question. So I'm going to get this to become 60 seconds first, which is 1 minute. So I'm going to multiply this first by 6. This is going to become 30 times. I'm building up the ratio. So it's going to become 60 seconds. But that 60 seconds is actually 1 minute. And I need this 1 minute to become 60 minutes, which is 1 hour. So now I'm going to just simply multiply by 60 now. As I want this 1 minute to become 60 minutes. So I'm multiplying this by 60 again. So it's 30 times 60. That's 1800. So this becomes 1800 times 2, and this now becomes 60 minutes. And that 60 minutes is now 1 hour. Then I need my 1 hour to become 24 hours. Because there are 24 hours in a day. So to get my 1 hour to become 24 hours, I now need to multiply by 24. So I'm multiplying this by 24. So I have 1800 times 24, and voila, I get that figure of 43,200 times. So 24 hours. And that 24 hours is 1 day. And that's my answer here shown. This is it. In 1 day, therefore shown. And that is it. That's not the only way to do it. Well, over there, yeah. Could have been that you take the 1 day and break down the 1 day into seconds. Then they divide that seconds by the 10. And for each 10, there are five flashes, and they multiply by 5. But I think this is the easy way to do it. Build 10 seconds up to 1 day by progressive. Yes?
They could just like convert the 24 hours into seconds, divide it by the 10.
That's what I just said. You could take the 24 hours, convert it to the seconds, divide it by the 10, and then multiply by 5. That's what I just said. You can do it that way as well. I want to see how many 10 seconds are in 24 hours. So you convert the 24 hours into seconds, divide the 24 hours that is now in seconds by 10, and then you multiply that now by 5, because you have 5 flashes for every 10 seconds. You're gonna get the same answer. So if you get this another way, there are maybe 4 or 5 other ways you can go. But I think this is a good enough way. All right. Terms here. And then you're thinking about the difference of 2 square case. But initially, all we have are common factors. So I'm seeing only a common factor of h in the 2 terms. And so I'm going to factorize the h from these 2 terms. H out of this. Then I check, can this be factorized any further? No. There's no difference of 2 squares there. There's no common factor there. So we are done. The question said completely. So you have to always check if any part that you get can be factorized any further. All right, so that is it. Then we come to the classic quadratic to factorize. And this one in particular can be factorized quickly because that's a prime number, 2. All the factors of 2x squared is 2x and x. But let's go through the process just for practice. The practice as you know, is to split this middle term into two parts so that you get 4 terms, and then you can factorize by parts. The process of splitting this middle term is to multiply the 2 n coefficients of that trinomial. So it's 2 times the -6. That gives you -12. Then you're looking for factors of negative, actually a -1. So a factor of -12 that add to -1. Now, since you want factors of a negative number, factors must be positive and one must be negative. The sum of the factors to be negative, you have to give the larger of the 2 factors of this -12. Now, I know the 2 factors right now is 3 and 4. But let's say you don't see 3 and 4. You can test and go until you find it. So I'll show you how you would do it if you could not see 3 and 4. After the 12, I'd have to give the larger one the same sign as this. So make this one negative. I'm getting -11. What is negative I want? -1 I want the sum to be, so that's not it. The next 2 factors of 12 would be 2 and 6. Again, give the larger one the same sign as this, minus. But 2 and -6 is -4. It is negative you want the sum to be, that's not it. 3 and 4, give the larger one the negative sign that this is. And when you add 3 and -4, you are getting the -1 that you want. So yes, this is it. It means then that we're going to split this -x using these 2 factors. So we're going to turn that -x into 3x minus 4x, or -4x plus 3x in any order. All right? So it means then that this now is going to expand out into, this remains 2x squared. Then this -x becomes 3x minus 4x, or if you like, -4x plus 3x. -4x plus 3x. And then this -6 comes back here. -6. Let me write this 2 better. Now, why did I put the -4x in front? Because it factorizes nicely with this 2x. That's why I put the -4x in front. I must always check that what you split the middle term into will give you that back anyway. Always do that check, which it would. -4x plus 3x will give you back that -x, -1x. They're going to go for the highest factor in those 2 terms, which is 2x. So factor the 2x out of these 2 terms. 2x out of this is going to give you x. 2x out of this is going to give you a -2. Remember, you must have the same thing in the bracket over this side. So the safe thing to do is to write by the same bracketed term over here first, which is the x minus 2. Then so, okay, in between here now is either a plus value or minus value. Or you know what that value is? You can, for example, divide this 3x in here, which is a +3, or you can divide this -6 by this -2, which still is going to give you a +3. So the factor out here is a +3. Then what it is now is that the x minus 2 is a common factor, and they are connected with this 2x plus 3. And so your factors now become 2x plus 3 times that common factor of x minus 2. Now, if you write it with the x minus 2 in front, this is still correct. So any one of those is good. So that is the answer. So it's this one or that one. Doesn't matter which one it is. 2 marks for that, guys. 2 marks for that. Let's continue. Solve the equation. The word solve in math means to find the unknown quantity. Find the value of the unknown quantity. The unknown quantity in this equation is the r. So to solve for r, you need to make just r the subject by itself. All right? So to make r the subject, we're going to expand it out, group the terms in r on one side, and everything else on the other side, leaving R as a subject. I'm going to expand this first. So I'm going to get R plus 3 equals 3 times this R is 3R, and 3 times this minus 5 is negative. Then these two terms in the same side of the equation. So I'm going to take this 3R, bring it over this side and subtract it. I'm going to take this 3, bring it over this side and subtract it as well. So I'm going to get this R remains. This 3R comes over onto this side and becomes negative 3R equals, this is negative 15, not 15, negative 15. Then this positive 3 comes on this side and is now negative 3. Then this R minus 3R is a negative 2R. 1 minus 3 is negative 2, negative 2R. 15 and negative 3 is negative 18. Then to make R the subject, I need to divide by this negative 2, divide it under here. Or we say we divide both sides by negative 2 like that. Anyway you want to look at it, this negative 2 is coming under here. To leave R by itself, negative 18 divided by negative 2. The negatives will cancel each other. And then the 18 divided by 2 is 9. So the R is equal to 9. That is it. R is equal to 9. Now, if you use another process and get R equal 9, still good. Now, we could have grouped the R terms on the right side as well. It doesn't matter. But R equals 9. So if you use another method and you get R equal 9, that's fine. All right. Next question. 2 marks for that again. Keep adding up your marks. This one says you have to make K the subject. This K right here. We need to make it the subject. What we're going to do is transpose everything away from the K and leave the K by itself as a subject. So the first thing I'm going to do is move this 3T away from this side and bring it over here. So I'm going to get the 2A on that side, and the 3T comes over here to become a negative 3T. That leaves me with pi times K squared. Then I need to move this pi. To move this pi, I need to divide by pi. So I divide this side by pi and divide this side by pi as well. So I divide both sides by the pi. So this will cancel, but I don't like to mark up my work. So the shortcut method is to say the pi over here is multiplying, sorry. So you bring it over this side, it divides. So you're gonna get 2A minus 3T, the entire side divided by pi, that leaves me the K squared. Then I need to move this square. The inverse of square is square root. And so I'm now gonna square root both sides to get rid of this square. I'm gonna square root this side and also square root this side. And square root will cancel away that square and leave the K by itself. Now, generally speaking, you really should be considering that this can be plus or minus, you know, guys. And when you calculate square root, it can be plus or minus. But I think for this question, they'll accept just the plus. All right? But generally speaking, you should be considering plus or minus. But for this time, I'm just going to leave with the plus alone. All right? So when the square root cancels away this square, that's equal to the square root of 2A minus 3T over pi. And so we can turn it around now and put the K on the left side. Let's turn it around. But I said make K the subject. Subject usually means it's on the left side. So the K then, this K becomes equal to this thing. The square root of 2A minus 3T divided by pi. And as I said, it can be plus or minus. It can be plus or minus. But I think if you just put plus alone, they'll accept it. All right? But it can be plus or minus. It can be plus or minus. This could be a plus or a minus right here. All right? Plus or minus. But I think if you leave the plus alone, they'll give it a marks just to see. All right? That is it. 2 marks again for that, guys. 2 marks. Let's continue. All right, so body should reach about 20 marks already. Don't. Yeah, about 15. Let's go. This one says 2 crops, potatoes, and on 10 hectares of 10 on a 10-hectare piece of land. So this is 10, everything important. 10 hectares. The number of hectares of corn planted C, so it's C hectares of corn that he plants, must be at least twice. Now remember, the term at least means greater than or equal to. If you must have at least $10 to do something, it means that you need 10 or more dollars to do it. So the term at least don't means less than, guys. Common mistake for persons to the word least and put the less than sign. But means greater than or equal to. The number of hectares of corn on this side is C, must be at least, meaning greater than or equal to. Now, twice means 2 times the number of hectares of potato, which is P. So 2 times P you're talking about. So it's 2 times P. Twice means 2 times, so that's 2P. So that's inequality from that statement, you know. It says we have to write 2 inequalities. The first inequality is in the fact that the total hectare was 10. And they are planting C corn and P potatoes. So the first inequality is that you cannot surpass the 10 hectares of land. So the number of hectares of corn plus the number of hectares of potato has to be less than or equal to the total hectares that you have available of land space. Has to be less than or equal to 10. That's the first inequality. And then this is the second inequality that they stated. C has to be greater than or equal to twice the P. Those are your 2 inequalities. You want to go to that? But okay?
Yes, sir.
Beautiful.
Yes,
So
sir.
2 marks again. So body should reach 18 marks after 2 gets done. All right? Let's continue. Number 3. Solid geometry question. So this shows an hexagonal prism, meaning the cross section is an hexagon. See it here? And it's a prism because of a uniform cross section. The end of it is the same dimension as this way. And it's a prism. So remember, the formula concerning prisms are that volume is cross-section area times length. And the length is always the distance between the 2 ends. And the A is the area of the end, the cross-sectional area. I don't think this question asking us that still. Question says, complete the statement. The prism has how many faces? So the faces are the flat sides. The faces are the flat sides. So like this is a face here. So they have 6 of them around the side of the image of the prism. 6 of them around the side. There are 1 at the back and 1 at the front. That makes 8. So I have 6 of them around the side, 1 over here, 1 over here. That makes 8 faces. The number of faces is 8. The number of edges. The edges are usually represented by these lines between the faces. All right. So let's count them up. You have 6 of them around the side. That's 6 of them around the side. And then you have 6 at this end. And you have 6 at this end. These straight lines are your edges. So that's 3 times 6, that's 18. Good? No, sorry. Yeah, man. 3, 6 are 18. Let's go again. You have 6 of them around the side. 1, 2, 3, 4, 5, 6. 6 around the side. Then you have 6 on this end. 1, 2, 3, 4, 5, 6. And then you have 6 on this end. 1, 2, 3, 4, 5, 6. What is that? So that's 3,
Yes,
6,
sir.
8. You have 18 edges. Then the vertices now are the points like where the edges meet, like points. Talking about these. 1, 2, 3, 4, 5, 6 here. And then over at this end, 1, 2, 3, 4, 5, 6. So the vertices are the points where your edges meet. So there are 12 of them. Let's get this right, please. 1 mark for each. 1 mark for each. Anyone you get wrong, you lose the mark. All right, 1 mark for each. Next one. So they don't ask us any geometry on this question. No solid geometry calculation. That's not the one thing. All right, this question now says, a sport club owns a field PQRS in the shape of a quadrilateral. It says the scale of the diagram, the scale of the diagram of the field of this field is shown below. So this is a scale. So what this means is that 1 centimeter on this diagram represents 10 meters on the field. That's what it means. 1 centimeter on the diagram is 10 meters on the field. So this is a question you have to measure. All right. So whatever you measure on this diagram, you multiply it by 10, you get the distance on the field in meters. That's what it means. All right. What they want us to do. All right. So in this part of the diagram, this part of the question, all construction line must be shown. All right. It says, the field divided with a fence from P to RS. So from P to this line, they're going to be putting a fence across there, right? So that different sports can be played at the same time. So like they want to play a sport over here and a sport over there. All right, so they're putting a fence across here, right? All right, it says each point on the fence is the same distance from PQ and PS. All right. So each point on this fence, so you're putting a fence here. And the fence must be the same distance from this line and from this line. And that distance to be a perpendicular distance, like so. Distance from a point to a line is a perpendicular distance. So this distance perpendicular must be equal to this distance perpendicular. That's what the fence has to be. For that to happen, this fence has to then bisect this angle in half. Cut it in half. Right? Because what it means is that this angle and this angle has to be the same. Because this distance must be the same as this distance. And this distance on the middle is going to be the same. So these two triangles are going to basically have the same dimensions over here and over here. So what it means then is that this angle and this angle must be the same. So the fence is going to have to bisect this angle. But understand that? The fence is going to have to bisect this angle. And how do we bisect an angle? Remember, to bisect this angle, you're going to make an arc of the angle, and you're bisecting that arc. I'm going to construct it. And to bisect that arc, from this end, you're going to make an arc up here. And from this end, you're going to make an arc down here. And then where those arcs meet, you're going to draw the straight line through them, and that is the fence. Let's do it on the construction sheet. Let's bring it up and do it on the construction. Let's do it over here. So I'm going to actually just sketch something and do it. Let's do it over here. Let's construct it over here. So everybody realize you have to bisect the angle, right? So how do we bisect an angle? To bisect an angle, you bisect the arc of the angle. All right. So I'm just going to draw something similar to this. I'm not going to get the exact thing. I'm just going to draw something similar to it. So a line down here, a line up here, a piece out there, and then a longer piece down here. Look something like that. And then this is P, this is Q, this is R, and this is S. And to get that line, we have to bisect that angle. So let's go now. There is our compass that we're going to use. The question must use the compass and draw the construction lines. So we're going to bisect this angle. So to bisect that angle, we need an arc of the angle. So open the compass to a reasonable length. Don't make it too wide. Don't make it too narrow. It's a reasonable length. And then you lock it. And then make an arc here. So when I bisect that arc, at this end, I make an arc out here, about where you know the bisector will be. Move it to the other end of the arc that you're bisecting, rotate it around, cross that one. Let's draw that straight line on the middle in green now. So when you draw your line now, right through this intersection where these two arcs meet, that is the line that is bisecting the angle. And you extend it right out until you reach that line RS. That is the line. That green line is what you must construct. That is what your fence would be. That green line is your fence. But to go to that, the next part of it says, the next part of the question says we have to write down the length of the fence and I want it in meters. So what you have to do is use your ruler now and measure the length of that line. So use your ruler. I'm going to measure it, and I don't know what the actual thing is on the actual paper. But this is what you'd have to do on the actual paper. You have to measure it now. 0 at one end. Rotate the ruler up. All right, let's say I'm getting 7.7 centimeters. Let's say I'm getting 7.7 centimeters on this drawing. Whatever number you get on your drawing, you have to go and multiply it by 10. So on the drawing, I'm getting 7.7 centimeters as the length. So on the drawing is 7.7 centimeters. See it here, put it in red. So drawing. The fence is 7.7 centimeters. And therefore, the actual 777 meters. Okay, multiply this by 10. Remember the scale was 1 to 10, guys? Scale was 1 centimeter to 10.
Yes, sir.
Whatever distance you get for drawing, you have to multiply it by 10. So you multiply distance, the actual distance of the fence. So you multiply this by 10 to get that one. That is the answer, 77 meters. Now, if you got 7.4 or 6.3, if you get 6.3 on your drawing, it's 63. If you measure and you get me? Provided that you bisect the angle, measure the length of that line. Whatever you get for the length of that line, you have to multiply it by 10 to get the accuracy of the fence. And that is that one, all right? 1 mark for that. I don't know what the actual distance is. I'm just using this based on the drawing that I have on the screen. I don't know what the actual distance is because I don't have the actual paper to measure. But that's what you'd have to do. All right, let's continue. Next question right here. Transformation. It says quadrilateral PQRS is image P per S is as shown on the diagram. So this is PQRS and this is P prime Q prime RS. Before you even start doing anything, you know that this is an enlargement transformation. Because there's a change in size. Enlargement has a scale factor and a center. An enlargement has a scale factor and a center. Scale factor can be positive or negative, can be a whole. The enlargement is this way, from this to this. So clearly, that's a whole number because the thing got larger, so like 2 or 3 or so. The next thing is that the scale factor is positive. Why is it positive? Because the image and the object pointing in the same direction. So for example, P to S is this way on the object. P to S is this way on the image. So the scale factor is a positive value. Now what value is it? The value is the multiple by what a length on the object changed, for example. So this side, for example, was 1 unit. It has grown to 3 units. That's a multiply by 3. So the scale factor right now is a positive 3. It's 3 because the thing has grown by a multiple of 3, and it's positive because the image and they are pointing in the same direction. When the scale factor is negative, the image will be inverted and pointing in the opposite direction. So we know before we start doing things that the scale factor is a positive. And we're going to need the center of the enlargement. Find the center of the enlargement, we can join the corresponding points and extend them back to where they intersect. So for example, P prime and P, join them. And we extend it back. The center of the enlargement is somewhere over here. So join P and P prime, that straight line, extend it back. Then you can join Q and Q prime again with a straight line, extend it back. So you join Q and Q prime, extend it back. Looking like this point here on my diagram. I'm going to check it. Because the scale factor also affects distance from the center. So I'm going to check it. So the distance, if this is my center, I'm going to check if this is my correct center. So the distance, for example, to P right now is 2. So the scale factor is actually 3, and this is the center. Then the distance to P prime must be 6. So the distance all the way up to P prime, is it 6? 1, 2, 3, 4, 5, 6. Yes. So this distance that was 2 has been multiplied out to 6 by a scale factor of positive 3. Mute the mic, please. So now I can conclude that this, in fact, is the center of my enlargement. So the center is at the point negative 4, 1. You can see it. Negative 4, 1 is the center of my enlargement. And I know they're going to ask me that. Question says, write down the name of this quadrilateral. That is a trapezium. See, it has one pair of parallel sides, those two horizontal sides. That's a trapezium. One of those common quadrilaterals that you must know. The trapezium. One mark for that. Then it says, PQR is mapped onto P prime, Q prime, R prime by an enlargement. Oh, so telling you it's an enlargement. Hold on. Right? It's a scale factor of K, which we know is 3. So we already know that the K is equal to positive 3. About a center point CAB. So CAB, we worked it out already, and it is the point negative 4, 1. And they're now telling us to use the diagram to determine the value of A, B, and K. So we have them. So the A is negative 4. Let's write it down here. The B is 1. And the K is 3. And those are your answers. We could have asked you to describe the transformation. And you would have said it is an enlargement of scale factor 3 about the point negative 4, 1. But they cannot change up this question this time. Most time they ask you to give a description. 3 marks for that. 1 mark for each of these things. 3 marks for that. 1 mark for getting each of those things.
Sorry,
next question. Yes.
Could you repeat the statement that we would have written if they asked us to describe it?
The statement that you would have written, if after to describe it, you would say the same thing that they said. An enlargement to the scale factor of 3 about the point that I put right here. So you're right, but this same statement that they gave you. Let me show you. You're right, but
Thank you, sir.
This statement. But instead of K, you'd have put 3. Instead of this, you'd have put minus 4, 1. You have to describe it. That same statement. You give the name and the components to describe it. All right. Next question. Number 4. That's a functions question. Simple function. We want to find the value of f of 4 plus f of minus 4. You're going to plug the 4 in there and also plug the minus 4 in there. So it becomes equal to 2 times 4 plus 7 over 5 plus. So the f of minus 4 means we'll plug in the minus 4 here now for the x. So it's 2 times minus 4 plus the 7 again over 5. So these two fractions, they right now have the same denominator. So they are related. So they have the same denominator as the answer. So we just need to add the numerator values now. So this is a positive 8 and a negative 8. They wipe out each other. And so you're going to be left with this 7 plus this 7, which is 14. So that is the answer. What are you going to do with that? Beautiful. 2 marks for that. Keep adding up your marks, please. 2 marks for that. Nice and easy. We're going for 80% today. Next one. Calculate the value of x, for which f of x is equal to 9. This can be done in multiple ways. Simple way, which is to put the f of x function and put it equal 9 and solve. What is f of x again? F of x is 2x plus 7 over 5. I want to put that equal 9. So the f of x is 2x plus 7 over 5. Put that equal 9. When you solve for the x, in this equation, you have your answer. So transposing everything away from this x. First thing is to take this 5 and multiply it up here. Always say multiply both sides by 5. Let's write out the steps. Multiply by 5 first. So we're going to have 2x plus 7 left on this side equals 45 over there. Next thing we need to get rid of this 7. Subtract the 7. That's the next step. Subtract 7 from both sides. We're going to have 2x alone left equal 2x, not 2, 7, 2x. This 7 come over here and subtract. 45 minus 7 is how much? 38, don't it? 38. Agreed? You don't know, divide both sides by 2. Or we can say, take this 2 and divide it under here. Same difference. We're going to divide now by 2. We divide by 2 next. You're going to have x by itself equals 19. So that is x equals 19. Very good? Nice and easy. 2 marks for that. These 2 marks easy to the door. It says hence or otherwise. No, this hence means that the answer up here can help you. That's what it means. The answer that we get up here can help you. That's what the hence means. Hence or otherwise, must determine value f to the minus 1 of 9. Remember what we did a while ago was f of x equals 9 and x came to be 19. So using the hence method, what it means is that f of 19 was equal to 9. That's from above, you know, from up here. But I said that f of 19 was equal to 9. We're using the hence method. We're using this method to do it, a hence method. We're using this to do it. So the f of 19 is equal to 9. I know they're asking for f to the minus 1 of 9. So we can put the inverse on this side. The inverse of f on that. So the 19 is going to be f to the minus 1 of 9. Let's explain it a little bit. Let's explain it a little bit here. What this means is that 19 is mapped onto 9 with the function f. So the 9 is going to be mapped back onto the 19 with f to the minus 1. That's what this is. F to the minus 1 of the 9 is equal to 19. So f to the minus 1 of 9 is equal to 19. So that is the answer. F to the minus 1 of the 9, which is this, is equal to 19. So we can basically just write that. So we can say, i.e., that is f to the minus 1 of 9, that's what this is, becomes equal to 19. 1 mark for that. So 19 is the answer. 19 is the answer, guys. Nice and easy. Next question. Coordinate geometry with lines on a graph. Please, the coordinate geometry. As you can calculate, measure up the gradient. I can say why I have to keep the steps. I like these coordinate geometry questions. They don't need to be calculating anything. Read it off from the graph. Let's look at it. Then graph below shows 2 lines, L1 and L2. This one is L1. This one clear for is L2. L1 and L2. Says L1 intersects the X and Y axis at 4, 0, and 0, 2. That's right here. This is 4, 0, that is 0, 2. All right, so give us those 2 points. That's on the diagram. And it says L2 intersects the X and Y axis at 1.50 and 0, negative 3. This is 1.50 right here. This is 0, negative 3 right here. All right? Right here is negative 3. Negative 3 right here. All right, what do I want us to do? All that information up here is shown on the graph. Stop talking. Take it low. But start getting low, please. All right. Determine the equation of line 1. So to get the equation of line 1, we can get from the graph. It's y equals mx plus c on line 1. Gradient of line 1 on line 1. How can we get gradient of line 1? We can measure it off. So line 1 here, let's use the red ink and show it. Just need to check the rise and the run between 2 points. Go from left to right, please. Between 2 points from left to right, where you know the coordinates for sure. Count out the rise and count out the run. This line is sloping down, so the gradient is going to be negative, because the line is falling as you go from left to right. So let's choose these 2 points, for example. Count out the rise and count out the run. Down here, this is 1 unit. 1 unit down to here. The rise of -1 because we went down. Then we're going to go 2 units to the right. Here, this is 2 units between -4 and -2. 2 units between here and here. This is 3, that's 1 unit. This is a run of 2 units. So this is the rise. And this is the run. Nice and easy. So the gradient of line 1 is rise over run between any 2 points, -1 over 2. And the C is clearly right here, the y-axis intercept. So C1, the C on line 1 is 2. The gradient is -0.5. That's all you need. So we'll come down here. Gradient on line 1 is -1 over 2, and C on line 1 is 2. So the equation becomes that. The equation, therefore, is simply y equals -0.5 x plus 2. Nice and easy. 3 marks for that easy thing there. Don't calculate nothing. 3 marks for that. -0.5 x plus 2. Continue. It says, what is the gradient of line 2? Given that they are perpendicular. So if they are perpendicular, the gradient of line 2 is -1 over the gradient of line 1. Next to the reciprocal. Because the gradient of line 1 is -0.5. This calculation is done by flip and change the sign. Flip and change sign of this one. So the gradient of line 2 becomes 2 over 1. It is 2. And you flip the half, it becomes 2 over 1. And you change the sign from negative to positive, which becomes 2. That is the answer. Easy as that. Or if you like, you put the -0.5 on here for the M1. It's going to work out the 2 anyway. So since the line is on the graph, you can double check if that is correct. Check the gradient on the line as well and see if it is correct. This line 2. Just choose any 2 points on it. Let's say I'm using these 2 points. For example, here and here, go from left to right along the line. Check the rise and check the run between those 2 points. See there? You go from this point to this point, from left to right along the line. I have to rise 2. This time, because I'm going up, that's a positive 2. Then I have to go 1 unit to the right. That's a run 1 unit. So the gradient of line 2 would be rise over run again. you were to calculate it, the rise is 2 and the run is 1. Let's start making that graph and leave them and don't come back. And that is equal to 2. So we could have gotten it again from the graph, but they told us, I think they wanted us to use this relationship in this question. That's why they told us about them being perpendicular. I think they wanted to test your knowledge of that one in this question. So I think that's what they wanted you to do. All right, and lines are perpendicular. Grade number 1 is a negative reciprocal of the other. If the lines are parallel, they have the same gradient. No calculation needed. All right, that is it. Next question is number 5, our statistics question. Question says, a group of 100 students estimated the mass m grams of a seed. So they all estimated the mass of 1 seed. The cumulative frequency curve below shows the results. So watch this now. These are the 100 students. This is the mass that they estimated. The ones who estimated the mass to be low are the ones down here. See that estimated low mass. The ones who estimated the mass to be high are the ones at the top. See, they're estimating the higher mass. Remember, once you see a cumulative frequency graph, it is that the values down here are either less than or equal to mass. So the graph is showing you how many students measure either less than a certain mass or less than or equal to a certain mass. Now, I can't know right off the bat, but there are no points on the graph for me to know. But I know that it's either going to show me less than or equal to mass. Sometimes the questions that you get kind of give you a hint as to whether the graph is showing you less than or equal to mass. All right? So let's see now. It says, use the cumulative frequency graph to estimate the median. Remember, the median talking. Everybody online can see the screen and hear me again?
Yes, sir.
Yeah.
All right, good. Right. So first question is asking us again to estimate the median. The median corresponds to the mass that the student in the middle of the distribution measured. Now, since there are 100 students, student in the middle of the distribution is the 50th one, half of the 100. So this right here is the position of the Q2. Q2 is the median. That's the position of Q2. To find the median mass, you have to read it off on the graph. So you come across on the graph right here, and you read it down on this line. Now, there's something that is important that we really should have done before we started this, which is to check the scale of your graph. In particular, you want to see what each of these little millimeter lines mean. So on the horizontal scale, that's 1 gram, that's divided 5 of these lines. So that's 1 divided by 5. 1 divided by 5 is 0.2, as 2 over 10. It means that each of these little lines is 0.2. Let's put it here so we don't forget. That's 0.2. Each of those little lines is 0.2. For example, this is 1, this is 1.2, 1.4, 1.6, 1.8. That's how you reach 2. That's horizontally. And vertically now you have 5 lines between up to 10 students. So again, it becomes 10 divided by 5, which is 2, means that each of these lines is 2 students. So each of these lines is 2 students. I can just double check it. See there? 2, 4, 6, 8, 10. Always check your scale. So I'm going to leave this 2 down here to remind me that each of those lines is 2. Leave this 0.2 there to remind me that on the horizontal, each of these lines is 0.2. So what is the value right here then? That value is 3.2. 3.2. So this value right here is 3.2, which is the median. So Q2 is 3.2 grams. Simple as that. 3.2 grams. This equals 3.2 grams. And you have to leave these lines on your graph to show the examiner how you use the graph. And the question says using your graph. So you leave those lines on your graph to show how you use your graph. Draw these lines with straight lines with a ruler, please. Don't draw it friendly like me. Next part says the upper quartile. The upper quartile is Q3. Third quartile. The position of the third quartile, 3/4 of the total students. 3/4 of total data. 3/4 of 100, or you can say 75% of the data. The 75% of 100 is 75. So the 75th student that is in the position of the third quartile. 75th student is right halfway between the 70th and the 80th. Everything must be precise and exact on a graph. That's right here, right in between here. That's 75. This now is the position of Q3. Position of the third quartile. Use the ruler, read it across on the graph again. You come across right in between here with a straight line. Till you reach the graph. Looks like it's coming right in between here as well, right in between here. Use the ruler and measure it down. Don't draw it friendly like this, please. Right in between here. Read it down on your graph. Don't draw it friendly like me. I can't draw it straight. I'm drawing it in my free hand right now. That's good to know where class are going. I have to leave. All right. Cool. I'm going to read that now. Remember, every one of those lines is 0.2. It means that right here now, just Q3 is equal to what? This is 4.1. No, sorry, this is 4.2, and this is 4.4. Right in between the 4. That red mark is at 4.3. It's right, please. 4.3. So it's 4.3 grams. What about that? 4.3 grams. So Q3 is 4.3 grams. Beautiful. Next one. They want the semi-interquartile range. Now the interquartile range, you know, the semi-interquartile range. Let's mind ourselves. The semi-interquartile range is equal to the interquartile range, because in maths, the word semi means half. So it's half of the interquartile range. So the interquartile range divided by 2. But what's the interquartile range? The interquartile range is upper quartile minus the lower quartile. Q3 minus Q1. And you're dividing that by 2. So this up here is the interquartile range. If you know Q3 already, we need to find Q1. Let's write it over here. Q3, you know already was 4.3 grams. And notice I put the grams unit of measure on my answers there. Look at it. All right, it's not just the value. You have to put the unit of the data, which is grams. And so we need to find Q1. We have Q1 here, so we need to find Q1. So Q1 corresponds to 1/4 portion of the 1/4 of data. First quarter. So 1/4 of the 100. If there are 100 students, it is the 1/4 position. Or the 25th percentile position. So that's right here. So the portion of Q1 is 25, the 25 student right in between the 30. That's 25. That now is the position of Q1, not Q1, no, that's the position of it. 25th student that the first quarter of the season. You come across on the graph here. It's like about in between here again. And right in between here. I think if you put on this line, I might give it a more precisely. Like this. That now is your Q1 right here. This is 2, is 2.2, is 2.4, the right here is 2.3. That is Q1 is 2.3 grams. 2.3 grams. Go back down here and write that. This is 2.3 grams. 2.3 grams. These are some nice numbers. This then becomes equal to 4.3 minus 2.3 over 2. This works out to 2. 2 divided by 2 is 1. It becomes 1 gram. Yeah. 10 minutes of water. Yeah. All right. After that, part says the number of students who estimated the mass to be 2.8 or less. So this is like that less than or equal to gram. Less than or equal to 2.8 grams of one. Looks like this is a less than or equal to gram. I'll put it down here. So this graph is showing us less than or equal to mass. Not showing us mass in it. You're showing how many students are less than or equal to any of these. Since you want to know how many students measure less than or equal to 2.8 grams, you need to find 2.8 grams on the graph. Read it up to see how many students that is. I don't have to make an adjustment. The value you get, that is the answer. Right? People tend to always believe that they need to be making an adjustment. You know? Let's do this part in green. 2.8, where's 2.8? 2 here, so 2.8 is this. 2.8. Right here. 2, 2.2, 2.4, 2.6, 2.8 is that line right there. You read it up on the graph until you read the graph. Up on this line, this is the 2.8 line. You read it up on the graph. You want to see how many students that is. Voila, right in this intersection. Come across here. That looks like 38 students. 30, 30, 32, 34, 36, 38. Don't give it away and put 34 in a guy. 38. Remember, you have to check the scale of graph before you start. That's 38 students. That is the answer. Don't make any adjustment. You have to tell me how many students measure less than or equal to that mass. That's 38 students. That is it. That is the answer. 38. 1 mark for that. So the answer is 30. What about that? 1 mark for that. 38 is the answer. Let's continue.
Yes, sir.
Beautiful. This one says, use the cumulative frequency curve, complete the table, and do something I know to be able to populate your frequency from a cumulative frequency curve. All you have to do, go on the curve and count how many people in these intervals. That's all you have to do. Count how many in those intervals. Let me show you this time. With your purple. So to do the first one for you already. 0 to 2 grams. 20%. If you're less than, or you can say less than or equal to 2 grams. So measure by 20 students. If you're, let me show you. I'm going to see it on the graph. If you're 2, then I got the 2 right here. You read it up on the graph. You get the 20 right here. The next interval is 4. That's what they're going. We just have got the 2, then 4, then 6, then 8, then 10. Let's do all of them so we can get all the values and show you. You have to do it, but I'm doing it to show you in case you have other values. So we're going 2. So 4 here now, 4. This is the 4 line. Go on the 4 line right here. Four line looks like 4 line. This is the 4 line. It's like right in between here now. Right in between here. This is the 4 line. Let's see how much weight is that. This looks like, but if it's 68, that looks like 69, which is like 69 right here. So between in this interval is 69 minus 20, 49. So between the 2 and the 4, we're going between the 20th student and the 69th student. So that's 49 students in this interval right here. 49. That interval. So that's 49. Right in here is 49. Blah, blah. Then, but there were 100 students. You can literally just add up these now and subtract from the 100. This one worked out for me. So this one, this is 50. And this time this makes 76. 76 already, right? And this makes 50. And 26 makes 76. So 100 minus 76 is the amount. What is that? You want to double check it. 100 minus 76 is the amount. 24. 24. Let's check if this 24 is correct by looking at the interval between 4 and 6. Must have 24 students in there if it is correct. Let's check it. Just making sure it's consistent. So let's see how much we got here. Taking up one of the right at this 9 up to 6. Right up to here. Look here now, we'll have to come right in between here again. That's given us 90, 92, 93. It looks like 93. 93 that. 93. Right there. 93 minus 69 is how much? 24. So that in between these two intervals, 93 minus 69, that's 24. That confirms that number. So everything is consistent. So that is how you know you can trust these values. Graph on your tables and your calculations consistent. 24. So that is it. That's a 4. Then now it says a student is chosen at random. Find the probability that a student estimated the mass to be greater than 6. Greater than 6. Greater than 6. What's it now? Get it from the table now. This is M greater than 6 right here. So everybody up here so measure greater than 6 now. So that greater than 6 started right here. M greater than 6 started right here that I have it, that I have circled right here. The M is greater than 6. If you read it from this way, M is greater than 6. So everybody up here greater than 6, which are these persons, 7 of them, measured it to be greater than 6. But understand that greater than 6 started right here. It includes the 6 persons here plus the 1 person here. Everybody up here, the measurement up here was greater than 6. So we're talking about these persons that greater than 6 we have up here. We got 7 out of 100. So the answer for this is 7 out of 100 persons. That's the problem. What good at that? What okay with that? The answer for that.
Yes, sir.
2 marks for that. We want those 2 marks. Good. Let's continue. Next question. Number 6. Measurement. This question says, the radius of each circle in the rectangle WXYZ shown below is 7 centimeters. See it here? 7 centimeters. It means that the diameter of each one is 14. And the diameter this way is also 14. All right? Question says the circle is exactly in the rectangle. Show that the area of the rectangle is this. To get the area of the rectangle, we need to know the width down here, the length across here. I multiply it. We can brief it from the So across here there are 1, 2, 3, 4 circles. So across here is 4 times 14 centimeters. What can I understand that? 4 times 14 centimeters. 4 times 14. 4 times 14 centimeters. So this one across here. 4 times 14 is how much? 52. That's 52. And down here there were 3 of them. 1, 2, 3. So down here is 3 times. Down here is 3 times 14 centimeters. Down here. And there's 3 of them. 1, 2, 3. 3 times 4. 3 times 14 is how much? 42. 3 times 14 is how much? Huh? Huh? 42. So the area then is right, 5 up here. It's supposed to be 52. This is not 52, 56. 56, right?
Yes, sir.
Right. So the area then is 56 times 42. That is it. Show that the area is. The area of the rectangle is 56 times 42. Did you work out to that number? Can you work out for me?
2,352.
Which is what they said to show, right? Centimeters square. Therefore, shown. 2 marks for that. That is it. 2 marks for that. Beautiful. Next question says, calculate the area shaded and pi is 22/7. Let's look at it. So the area shaded is the area of the rectangle. Subtract the area of those 12 circles, don't it? That 12 circles. 4 across here. And 12 circles. So we need to find the area of the rectangle, which we know the area of the rectangle already, minus 12. 12 of the area of each of those circles. But that's that. The area of a circle is pi r squared. The area is 7. Let's go. The area shaded equals area of the rectangle minus 12 times the area of one of those circles. And there were 12 of them. And the area of a circle is pi r squared, don't it? Pi r squared is the area of a circle. So what's the calculation? Here the rectangle, we have it already. Is this figure up here? What is it again? 2352. So this is 2352. We have multiplied. It's supposed to be a minus type. Minus. We have the rectangle minus 12 circles. Minus 12 times pi r squared. And pi is 22/7, right? So it's 12 times 22/7. It's on the 2. Minus 12 times pi is 22/7 times r squared. That's 7 squared. That's what we're working on. So I put that in the calculator 1 time. We have to break it down piece by piece. 514 you get? Somebody get 514 too? All right, man, trust me, you know. Centimeters squared. All right. I'm trusting you. 504. Other person got that too? All right, good. Right, just 3 marks for that. 3 marks. Next question. Oh, that question done. This question says, diagram below, not drawn to scale, shows, I'm talking now, please. Shows a triangle MNP in which the angle MPN equals EMN is 52. So these two equal. So that's an isosceles triangle. And then this side over here is 12. So since this angle opposite this side is 12, then this angle opposite the same 52 must also be 12. So automatically over here, we're actually 12.5. Must be 12.5 centimeters as well. So that's an isosceles triangle right there. Also, since we know these two angles, we are blessed. You can find this one. This one becomes 180 degrees minus 2 times 52 degrees. Don't it? Which is what? 76 degrees, just like that. So we know that angle before we even start doing any work. So I populated the diagram. Question said, say the type of triangle, isosceles. Isosceles. Two angles equal, two sides equal. Isosceles. Next one. Determine the angle P and M. Oh, that's this one that we just found, right? Good. So it's 180 degrees minus 2 times 52 degrees. But the total angle in there is 180. That's 76 degrees that we just got. We worked out before they even asked us. 1 mark for that. Next part says, calculate the area of a triangle. So to get the area of a triangle, we're going to use the trig formula for the area of a triangle. It's on the formula sheet. Let's see. On the formula sheet, half AB sine C. The formula sheet is here. Yes, see it here. Trig formula for the area of a triangle is this one. See it here, so? That's when you know two sides and an angle between them. A, B, C between them. That becomes the area right here. After product of two sides, then the sine of an angle between them gives it the area of a triangle. I'll use that formula down here. We're not gonna use half base and pi. Right here. So we're gonna use half the product of these two sides and the sine between them. See that? That's what we use it. It becomes equal to half 12.5 times 12.5. I put 12.5 squared, and the sine angle between them is 76 degrees. Put that in the calculator over here. 75.8. All right, that's just you know 75.8 centimeters squared. What has got that? All right, you're all very bright. Go to give it to 3 significant figures. Don't put 70. When the answer is not exact and the question did not tell you the level of accuracy you must give your answer to 3 significant figures, please. That's a standard. All right, 75.8 is good. 9 marks. Beautiful. Next question, pattern question. Pattern and sequence. This one says, sequence of figures is made up of stars using dots and sticks of different lengths. So the first 3 figures in the sequence are shown below. In the pattern here. And this one don't ask to draw on a 4th one. And lucky, this one didn't ask to draw on a 4th one. Most of the asked to draw a 4th one, but this one didn't ask that. They all got away with this one. It says, study the pattern of numbers in each row of the table. Each row relates to a figure in the sequence of figures started above. Some rows have not been included. All right. And I want us to complete the rows 1, 2, and 3. So I want us to complete this row, this row, this row. Now, as usual, we like to do the formula row first because the formula row can help you to complete these other rows, especially when it's not continuous, right? So we're going to complete for this column first. So look at the numbers. These numbers, they are increasing by 12. So since they are increasing by 12, 12n is a part of the formula. But then the first figure is just 12. So it means that we don't need to add or subtract anything. First figure is just 12. And 12 times 1 is 12. So that's the formula for that one. But over here, we're increasing by 12 again. So again, 12n starts the formula. But you increase it by 12, so 12n starts the formula. So the first figure has 13. 12 times 1 is 12, into add 1. So it becomes 12n plus 1 is the formula for that column. 12n plus 1. Then now, this now is just the next one from this, so we can continue this trend of adding 12. So if you add 12 to this, you're going to get 60. And if I add 12 to this, you're going to get 61. And in fact, this is always one more than this. So this is 61. Or you could take the 5 and drop it on the formula and get 12 times 1. 12 times 5 is 60. Or if you drop the 5 on this formula, you get the same 61. Then we need to do for this figure. If we get the value for here, what we're going to do is equate this to this. So for this figure, it's going to be that the 12n is equal to 156. So the n is equal to 156 divided by 12. What is it? 13?
13.
Right here is 13. Beautiful. And this one is easy because it's always one more than this. So this was 157. Or you could put the 13 on this if you want it. But that is it. All right, beautiful. That completes the table. Nice, easy one. 2 marks for each. Well, 1 mark for each figure. 1 mark for each of these figures. That's how it is. 1 mark for each figure. So mark as you go, please. Heading for 80%. We want 80%. Next one. It says the sum of the number of shots in 2 consecutive figures are recorded. This information for the first 3 pairs of consecutive figures are shown in the table below. That's for the first 2 figures, second 2, then the next 2, the next 2. All right, consecutive figures. The total number of dots in figure 7 and figure 8. One figure 7 and figure 8. Now remember, what is the formula for the number of dots? Can you use that? This one, right? It's 12n plus 1. So remember the formula for the number of dots is 12n plus 1. And for the 7th figure, the 7th figure becomes 12 times 7 plus 1. And for the figure 7 plus, for figure 8 becomes 12 times 8 plus 1. That gives you the total, everybody. But understand that? This is for figure 7, that's for figure 8.
Yes, sir.
Figure 7. That's for figure 8. Using the formula there. What is work out in total? Somebody tell me what is work out in total? Huh? Yes, what is work out to? Everything. Now work it out. 182, 182. Everybody get that? People got different answers. Everybody get 182? Let's continue. Next one says figure n plus 1. The formula, remember again, is 12n plus 1. They want figure n plus 1. Figure n is when you put the n there. And the n plus 1 is when you put the n plus 1 there. So it becomes equal to 12n plus 1 plus 12 times n plus 1 plus 1. But answer that? So this is figure
No,
n,
sir.
figure n plus 1. But answer that?
No, sir.
No? All right. So when the figure number is n, this is a formula. When the figure number is n plus 1, all you do is take this n plus 1 and replace the n there. That's how I get this.
Okay.
And that's good. And so we're adding up everything now. So this inside here is actually going to reduce to 12n plus 12 times 1 is 12 plus 1 is 13. 12n plus 13. That's what this is going to become. So the final result is 12n plus this 12n, that's 24n, And 1 plus 13 is 14. That is the final result. 24n plus 14. Very good. 24n plus 14 is the answer for that. 2 marks for that one. 2 marks for that one. All right, let's continue. Next question. Read section 2 now. Yes. We're going to go. 3 questions to go. Number 8, 9, and 10. Simultaneous equation of a curve and a line. Use substitution. This one, substitution to me is really x, because this has x as a subject, that has x as a subject. We can substitute for the x. Take this and substitute for the x right here. All we have to do. Substitute for the x. That's the easiest substitution to make, rather than go make y the subject. When you have a simultaneous line and a curve, the easy thing to do is use substitution. Right? We're going to replace x here with a 5x. Remember now, at the point of intersection, that's what simultaneous equation means. The x value on the curve and the x value on the line is the same. So you can substitute them. You can substitute one for the other or equate them. When you make that substitution, sub for x, sub for the x, you're going to get y squared plus 2y plus 11, and this equals, and then this x now you're replacing it with this, which is the 5 minus 3y. That's now a part of the equation in y. It is the transpose away. Here and then start. If you don't have square term in there, that's y squared. This minus 3y comes over here, becomes a plus 3y with this, gives us 5y. You're gonna have plus 5y. Then this 5 comes over here and subtract from that 11, or give me 6. 11 minus 5 is 6. And that's a plus 6 equals 0. This is the factor of factors of 6 that add to 5 is 2 and 3. So it's factorized easily. Only factor of the y squared is y and y. Factors of the 6 that add to 5 is 2 and 3. Signs are the same, they are both positive. Plus and plus equals 0. Whether this factor equals 0 or this factor equals 0. If this equals 0, you take this 2 and bring it over here, become negative 2. So you're getting y equals negative 2. Or, hold that door, please. Or, if this equals 0, we're going to be transposing the 3. And we're going to get y equals negative 3. But we're not done. You have to find the y value, x value to go with this, and x value to go with that. So we're going to substitute in this equation that has x as the subject. Put it in red. We're going to now sub into x equals 5 minus 3y. All right? First one is where y equals minus 2. The x is going to be 5 minus 3 times minus 2. This minus 3 times minus 2 is a positive 6. 6 times this 5 makes 11. Remember, this is the x value. This is the y value. If you're putting it in bracket, you have to put the x value first. 11 minus 2 is 1 point. Other point is where y equals minus 3. Y equals minus 3. Put the minus 3 in the equation there for the x. The x is going to be 5 minus 3 times minus 3. It's a positive 9. 9 and this 5 is 14. So the other point is where x equals 14, y equals minus 3. So you're putting it at a point, number 14 minus 3. You have to put the x value in the bracket first. So these are your answers right here. That's one pair. That's the other pair. That's an answer. That's an answer. Those are the 2 points of intersection. 4 marks for that. Now, if you leave them individually, you put these two together. For example, if you write x equals 11, y equals minus 2, x equals 14, Y equals minus T like that. Let's give it a mark still. All right. Gotta go to that. All right. Moving right along. Part B, function. No, that's quadratics. That's quadratic. Here, they want us to write this in this form. In other words, they want us to complete the square. So remember, in this class, we use X and XT method. We learned with the H and the K, no problem. In this program, you write this expression as A into X minus XT squared plus YT, where the T means turning point. So XT is the X value at the turning point. YT is the Y value at the turning point. The formula for XT is minus B over 2A. If the A method is B over 2A. I have a plus here, I put a minus here. As I'm getting the X value at the turning point straight using this method. So that's going to be minus C. From this expression, what is the A, the B, and the C? Let's write them out. The A is the coefficient of the X squared, which is 4. B is the coefficient of the X, which is negative 8. We have to put the negative on it. C is a constant term, which is a negative 2, not negative 2. So the B right here now is a negative 8. So this is minus a negative 8 of the B divided by 2 times A, and the A is 4. That becomes a positive 8 over a positive 8, which is equal to 1. The X value at the turning point is 1. So 1 is coming right here for this X. If that's 8, you'll get negative 1 for your 8. It is the 8 method, over 2A. But since this is a whole number, I can find my Y by the substitute this function right here to get my YT value. I don't need to see the formula. The Y value at the turning point is going to be 4 times 1 squared minus 8 times 1 minus 2. That we plug in this XT value back into the function to find the Y value that corresponds with that XT value. So working this out, what do we get? That's 4 minus 8, that's negative 4. The minus 2 makes negative 6. So it means that this expression now becomes f of x equals the A is 4 into x minus xt is 1. Don't forget the square, and the plus yt is negative 6. Negative 6. This is the answer. That is, use the H and K method, no problem. Let's get the same answer. Right? Next question. Here's the minimum value. Minimum value is this YT value. The minimum value is of the YT value is negative 6. The lowest Y value on the graph, negative 6. Next one. Determine the equation of axis of symmetry. The axis of symmetry is always x equals that xt value. That's why we do it this way in this class. X and yt. What is xt? Xt is actually 1. X value at the turning point. So the equation of axis of symmetry is x equals 1. This is the answer right here. X equals 1 is the equation of axis of symmetry. After that. Next question. I think in other places, people put x equal minus 8. That's also my that I use the H method, and H is B over 2A. All right, but the answer is supposed to be the same in the end. X equals 1. Next question. Speed time graph. The speed time graph below not drawn the space show the 3-stage journey of a car over a period of 40 seconds. Here 40 seconds. Here it is accelerating from rest. Here it's traveling at a constant speed, no acceleration. Here it is decelerating, slowing down to rest down here. All right, this is what I asked us. It says determine the acceleration of a car on each of the 3 stages. Acceleration is gradient. Remember, acceleration on a p-time graph is gradient. Rise over run. So for stage 2 up here, the gradient is 0. For the horizontal line, the rise is 0. So for stage 2, acceleration is equal to 0 meters per second squared. Acceleration unit is meters per second squared. 0 on the stage 2. It's horizontal line, but there's no rise. Rise is 0. In stage 3, gradient is negative. See? Gradient is negative in stage 3. So you're basically rising down. So the rise is this 12 down, negative 12. And the run from here to here is what? 8. So the rise is negative 12, the run is 8 on this line. Here, negative 12 over 8. So here, acceleration in stage 3 is negative 12 over 8. What are we referring to? Negative 1.5, don't you? Negative 1.5 meters per second squared. Now watch me now. Very important. If the question I'll ask you for the retardation or the deceleration, you would not put the negative on it. Because deceleration already means slowing down. So you would not put the negative on it. So I'm going to make a note here. The deceleration or the retardation. That ask for that. Will be equal to just positive 1.5 meters per second squared in stage 3. So ask for these, you don't put the negative on it. Don't put the negative on it. That's the deceleration or the retardation because it already means negative acceleration, slowing down. 3 marks for that. So looks like it is 1.5, well, not 1.5. I think it's 1 mark for this and 2 marks for this one. 1 mark for this, 2 marks for this one. That's why you get the 3 marks. 1 up here, so 2 down here, so it's the mark to make 3. Mark it like that for me, please. All right. Next question. That question is done. Circular measures. So the here. Negative. Right, right. Right. Next question says, the stone below has a center O and the point A, B, C, and E line and circle. So a straight line passes through the point A and B, and the angle CDD is 49 degrees, and angle OAB is 37 degrees. Everything that they set up here is shown on the diagram. So that is good. You don't have to go back up here to read anything. 49 degrees is here, the 37 degrees is here, and those lines here. Now, this is the diameter. You all know that diameter subtends 90 degrees at the circumference, right? You need that this angle right up here, so it's 90 degrees right now. So this is the right angle triangle. Angle is 90 degrees. And so these 2 angles add up to 90 degrees as well. All right? So right away, you know that the y angle degree down here is going to be 90 minus 49. We see that already. 41. And then now, this triangle is isosceles. Why is this triangle isosceles? Because this line is a radius, and this line is also a radius. So that's an isosceles triangle. So it means that this angle over here is the same as this one, 37. In an isosceles triangle, if you know one angle, you are blessed, but you can find the other one easily. All right? So this angle is 37, so this angle is also 37. We'll see those things before we start doing anything. So this angle up here is going to be 180 minus 2 times 37. Good. All right. Let's see what I ask you now. So that was just recognize a couple of things before we start. That's what I said. Write down the mathematical name for the straight line BC. That one is a chord. Line joining 2 points on the circumference is a chord. You tell you to ask this question in CSEC, I told you. Next one says the line OA. And the line from the center to the circumference is a radius. And the line from the center to the circumference is a radius. 1 mark for each of those. 3 marks those and nobody should be getting those wrong. So after this one, that will be a diameter. Right? That's DB is a diameter. Let's continue. Determine. Good after this line. Let me test it. Good after this line. This line. This line here. This one. Name of that one. I told you one this. Good after that line. But what are that line? The whole of it. Not just this part to this part. That's a chord. This was
It's
L
a
and this was
secant.
secant line. Thank you very much. That is it. Beautiful. Somebody online for secant. Who said secant or whatever? Somebody
Jaden.
online. You're Jaden. Good. That's a secant. Thank you very much. Never see the ask about that line in secret before, but that is it. That's a secant. All right, let's continue. Determine the value of each of the following. So detailed working where necessary and give a reason for the answer. We cannot just write down the angles, guys. You have to show you get there. Are they going to say one of the rules, surface area rules? I show calculation, trigonometric calculation, geometric calculation, right? Polygon calculation. So all those things. The value of x. Let's look back at what x was. So x was in this triangle. I want to tell them that this triangle is isosceles. So these two angles is 37. So this one is 180 minus 2 times 37. But to go to that, I want to tell them that this angle is isosceles. This angle is isosceles. So I want to say it is 180. X is equal to 180 degrees minus 2 times 37 degrees. Now notice, I'm leaving off the degrees. Anybody can tell me why I'm leaving off the degrees off it? So we're finding the value of x. And the x in the diagram had the degree on it already. So the x is just a value. You get me? I don't think CSEC is going to penalize you for the degree on it, but that's the right thing to do. So the x is just a value. So I'm leaving off the so it becomes 180 minus 2 times 37. What if we work out to? What that work out to? Who did it?
106.
106. Again, if you put the degree on it, I think they give it a mark. So x degrees is 106 degrees. Let's do it like that. Put on the degree over here. So the x is 30, 106. Now we have to write the reason, right? I want to tell them that the triangles are isosceles and the total angle is 180, right? So if you say something like total angle in the isosceles triangle. Which triangle is it again? Let's name it. It is triangle OAB. OAB. Isosceles triangle OAB. OAB. Okay. Said isosceles. That is why we have that 2 times 37. That is understood. Isosceles. All right. That is that. 106. Angle Y. So we're gonna get angle Y again. What I said, this triangle is this triangle is 180. I'm gonna put this angle is 9. I'm gonna put on the diagram right here. Okay, this angle is 90 degrees. That's the subtended by a diameter, right? 90 degrees. That's an angle subtended by diameter. diameter BB, right? Diameter BB. That's why it's 90. That's a part of my solution. I want to say no, these two angles are up to 90. They are complementary angles, right? These two angles no must add up to 90 because this one is 90. Alright, so those two angles must add up to 90. So the y becomes, the y is now equal to 90 minus 49 degrees. That's 41, right? 41 degrees. Right? Okay, so total angle in triangle. Can we do it again? The triangle is BCD. That's a part of my solution, and I have it on the diagram base, so that is accepted. And triangle BCD is 103 degrees. And because one of them is 90, the other two must add up to 90. That's why we just need to subtract 49. What about that?
Yes, sir.
All right, bearing question now. Bearing. This question says, diagram below not to scale shows the root of a shape using from P to Q and then to R. Don't care about those. So coming from here to here, then from there to there. All right. Question says the bearing of Q from P is 133 degrees. Let's show it right here, 133 degrees. Of Q from P. And the angle PQR is 56 inside here. So show that on the diagram. So everything that they have set up here is on the diagram. So just need to just work out. So it says, calculate the value of angle W right here. Angle W right there. What is now? Multiple ways to do it, but I'm going to show you a nice way. So this line down here parallel. There are two north-south lines. Both of them are joined by this line. It's called a transversal line. A line crossing two parallel lines, a transversal line. It means that these two angles are alternate angles. This one and this one. They are alternate angles, so they are equal. So this one is 133, then these two must be 133 as well. So the double becomes 133 minus 56. Now, this is not a question you have to give reasons and all them things. Just show your calculations. It's not like the question that we just did. You have to tell them it's Z angles and all that. Just do your calculations. So W is 1. I can appreciate that. We're going to do that down here then. So the W was equal to 133 degrees minus 56 degrees. What work out to? What work out to? Nobody did it? Huh? 77 degrees. All right.
77 degrees, sir.
Thank you. Thank you. These students in here not working with me. Let's look good. Next one. 2 marks for that. We want the bearing of P from Q. Remember, when you're doing bearings, you must always note the from position. So going from Q to P, the bearing must be measured at the Q. As a clockwise angle from the north and at Q to P. Let's look at it and put on the diagram from Q to P. So Q here to P. So one at the bearing of this direction up to P. Go get that bearing. So this is the north line. At the front position, we want to calculate the clockwise angle all the way around here. That's the angle that we want. That's the bearing angle the question is asking us. It's kind of easy because we just work out the W, right? And so if you take that big red angle, divide this blue line down here, break it up into parts, it becomes 180 degrees up to here, and 180 degrees over here, plus 77 degrees inside here, plus 56 degrees inside here. But understand that. So the 180
Yes, sir.
plus 77 plus 56 gives you that angle that I want. We want that big red angle. That red angle, that red angle is the big one we want to discuss. 180, right, the 77 that we found inside. Inside here was 77 degrees. This was 7. 180 up here, plus 77 up here, plus 56. We just want the body to see it. That's the angle that we want. All right? That angle is 180 plus 77 plus 56. That's right. Equal to 180 on the straight line plus 77, which is a W, plus 56. What I work out to?
313.
313.
313 degrees. No, there's another way we could have found it, guys. Show you another way we could have found it. Let me show you another way we could have found it. So we say it is this angle we want still in there, right? Another way to do it is that we could have found this angle right here. This angle are four interior angles, because they appear to be in these two parallel lines, two angles. These two angles are what we call four interior angles. They add up to 180 degrees. All right? Because there are angles between these two parallel lines, line by this line and the base. So we said that angle here, this angle right here, is 180 degrees minus 172 degrees. How much is that? 47 degrees. Then no, this red angle is 360 minus 47. But this is a short 360 minus 47. So this will be 360 minus 47 degrees. That's another way we could have found it. For the same answer. But I get that, we get the 313,
Yes.
right? 313 degrees. So that's another way we could have that. So anyway you do it, fine. All right, we don't put this in. Let me take it down. All right. So that's another way. Let me write this over here. Open the part. 360 minus 47 is 313. Let's go about the 47 on the diagram. This angle is 47. Cos it will be 180 degrees minus 130 degrees. Whole here angle, right? That's what that would be 47. And then this angle that there angle go on here. That was the blue that out. Two ways to do it, right? Inside here is 77, remember. Let's continue. What is the one? Let's calculate the distance RP. So want to calculate the distance RP in this triangle. So now we're going to be working in this triangle that I'm marking out in blue. This side over here, we have the calculation of two sides and an angle between. Using the cosine rule to find that. Sorry, cosine rule. This has an angle between in the cosine rule. So it's 210. Let's write them down. It's 210 kilometers, 290 kilometers. All right, copy this one. All right. So remember now that cosine rule starts out as if it is Pythagoras' theorem, right? So the RP squared will be equal to this side squared plus this side squared as if it was Pythagoras' theorem. 210 squared plus 290 squared. That's what it would be. Pythagoras' theorem squared. Not Pythagoras' theorem. You have to subtract a piece. Subtract twice the product of these two pieces. Of these two sides. And the cosine of the angle between them. And we don't have to put the square on this just like particles theorem. We can take off this square and just square root everything and drop off this square and keep it simple. Like that, quick and fast. But go to that.
Yes, sir.
Good. And then we do one calculation for RP. Anybody work this out for me? What is it?
245.1.
245.1, but at 3 figures, say put 245, that's good. If you put 245.1, good enough. Well, you must put 345 kilometers. Make sure you put the kilometers as well. That's how for the distance. I put the units up there. 3 marks for that. Question done. 1 question to go. Remember, we're doing another paper after this, right? That's the next paper. Yep. Remember, so we're working 9 o'clock. We're going to do the next paper at 3 o'clock. Start at 3 o'clock. Finish at 5:40. And then I start it at about 6. I'm going to finish before 9. I'll go home. All right? So start.
So can you repeat, please?
Let's do this next last question quickly. So
So can you repeat, please?
Huh?
Can you repeat what you say about it?
We are going to do another paper after this class. Another 2 or 40 minutes paper. When we finish, I'm going to work through it again. Understand that? Person who has to repeat, you hear me?
Yes, sir.
All right, so that's what we're going to do. All right? I'm going to put up another paper. It's going to be January. I'm not telling you which paper is going to be here. There's going to be another paper. I'll just give it here right after. Let's go. This question says, matrix M is this. Map the point R onto R prime as shown in the diagram. So mapping this point up to this point. And we have to decide which transformation it is. All right. Determine the point divided of P and Q. So how it works that you apply this matrix to this point and it is equal to that point. So we're going to set up an equality of matrices with it. What is the coordinate? The coordinate of R, starting point. R is the point 2, negative 5. 2, negative 5. And the image point R prime is 5, 2. So be nice, please. 5, 2. And when you apply M to this, equals that. That's how it works. Let me set it up for you. When you apply M to the point R, the answer is R prime. So we're setting it up now. So M is a matrix. What is it again? 0P20. 0P20. So 0P20 multiplied by the matrix for R, which will be then 2, negative 5. 2, negative 5 is equal to the vector matrix for R prime, which is 5, 2. 5, 2. So we're going to set this up now. We're going to use the fact that this 5 is equal to this row times this column. Set it up like an equality of matrix. Right? Let's do it down here. So 0P times the 2, negative 5 is equal to this 5. So it means that 0 times 2 and P times negative 5 is equal to 5. So the 0 times 2 is 0 plus. Hello. Stop talking now. Go outside now. Don't make me get upset now. So the 2 times P times minus 5 is minus 5. Is equal to 5. So therefore, the P equal negative 1. What can that? This 2 right here is this row times this column. Q is going to be 1 right there for sure. So the Q0 times the 2, negative 5 is equal to 2. So this Q times this 2 is 2Q. This 0 times this negative 5 is 0. That's all equal to 2. So clearly the Q is equal to 1. That is it. So the P equals 1. That's not 1. One of them is negative 1. This is negative 1. Times negative 1. Yeah, because you know I get me upset. That's why I make mistake. All right. The P is negative 1 and the Q is 1. So that is it. So the matrix, let's write the matrix over here first.
Q, sir.
And the M is, yes,
Yes, sir.
0,
If
minus
it's
1,
0,
1, 0. Yes?
so if it's 0 minus 5p equals to 5 and you carry over the 5 to divide it, you can change that positive?
No, you're dividing by the 5. So this really becomes minus 5p equals 5. You're dividing both sides by a negative 5. The 5 becomes p, that becomes negative 1. See that?
Yes, sir.
You're dividing by the negative 5. The sides two and divide. All right. That is it. Next one said, describe the transformation fully. You must look at the matrix and know it. It's the anti-clockwise 90-degree rotation about the origin. You have to learn to look at the matrices and know them. All right? So if you rotate anti-clockwise, that is here about this origin. That's what it is. 90 degrees. Anti-clockwise 90-degree rotation about the origin. You don't want to be figuring this out in an exam. You want to just see the matrix and know it, right? So it's an anti-clockwise 90-degree rotation about the origin. You don't say about the origin, you're not getting all the marks. You're describing a rotation, you have to give everything. You have to give the name, the 3 components of rotation. Angle, direction, and the center. You're getting a mark for each one. You cannot just say it's a rotation. You have to give the name, which is rotation, and the components. Rotation has 3 components, angle, direction, and center. Remember also, guys, that anti-clockwise rotation is positive rotation. So you could have said a positive 90-degree rotation about the origin. Anti-clockwise rotation is positive rotation. Clockwise rotation is negative rotation. Anti-clockwise rotation is positive rotation. Clockwise rotation is negative rotation. So instead of saying an anti-clockwise 90-degree rotation, all right? Anti-clockwise rotation, positive. All right, that finishes that part. I'll come to the very last part. That's nice, easy vector question. Question says, PQRS is a parallelogram. Once a parallelogram, you know the opposite sides are equal vectors, right off the bat. So the vector PQ, that's this side. No, that's up here is U. It means that the vector up here is also U. Let's put on the diagram right away. This vector up here is also vector U. The opposite sides are equal vectors. So the vector PS down here is B. So this side is the same length and same direction. So the vector up there is also V. So the vector across here is also vector V, taking it from Q to R. Is also V. So the vector from S to R is U. Vector from Q to R is V. All right, so I populated the diagram. It also said that M is on QS in the ratio of QM to MS is 1 to 2. You can put this ratio on the diagram and see the parts. So QM is one part, the MS is 2 parts. 2 parts. So the line has 3 parts in total. Means that is 2/3 of the whole line, and this is 1/3 of the whole line. All right, those gonna become important. There's 2 parts, 1 part. Question says, calculate the vector QS. How do we go from Q to S on the diagram? Easy, you can see it here. Come out to R with the V, and then go down to S with the minus U. Why is it minus U? We're going in the opposite direction to the U. But it simply is just V minus U. Simple as that. But I say that. Next one. M. 2M is this. QM is a 1/3 of the QS that we just found a while ago. Just 1/3 of the QS. We just found the QS. QM is just 1/3 of it on that diagram. So QM is just 1/3 of the QS that we just found. QS is V minus U, so we're doing 1/3 of V minus U. So it's 1/3 of the V. And 1/3 of the minus U become minus 1/3 U. That is it. 1/3 V minus 1/3 U. Start down here. Show that MR is this. Now look here. To show that MR is this, you just go about calculating the MR. And it must come to that. That's all you have to do to show that MR is that. Calculate the MR, and then you want to see that it will work out to be this. So we need to look and see how we would get MR on that diagram. Let's look at the diagram. MR. M to R. Go from M to R, I will come down to S first, and then go from S to R up here. So the M to S, and that MS is 2/3 of the 2S, plus that one. Let me do it on the screen so you can see. Let me do it on the screen so you can see right here. So I'm saying to go from M to R on this diagram. I'm going to go M to S first. M to S first. And then, remember the plus and then we're going to go S to R up there. S to R up there. Next. S to R. S is a part of this QS that we just found. It's actually 2/3 of it. So this MS is just 2/3 of the QS. And the SR is just U. U. You can continue with this calculation and next page. Let me copy it down. Putting it here. Remember that the QS that we found was V minus U. And now we need 2/3 of it here. So this becomes 2/3 of the V minus 2/3 of the U. That's what this becomes. 2/3 V minus 2/3 U. That's what this becomes. And then you're adding this U out here, plus U. You're going to consolidate these two U values, or these two U terms. So this remains 2/3 V. Now this U is the same as 3/3U, because I want to put it have the same denominator as that one. Then I'm doing 3 minus 2. 3 minus 2 is 1. So that then becomes plus 1/3 U. Plus 1/3 U. And all I have done here now is factorize a third from these two expressions. You get that? So, factorize a third out of these two things. Look at it. All I have done is put the a third from this. You can get the U. Factorize a third from this. Then we left with the 2V plus 2V. That's what they have here. So therefore, shown. 2 marks to do that word, guys, to show that. Simple as that. So to show that the MR is this, you calculate the MR and work it towards what they have. You never get it right, you need to go and do it again. All right, next question says no. T is the midpoint of PQ. Prove that the points R, M, and T are collinear, meaning that they are on a straight line. Let's put another diagram. It's the midpoint. Put another diagram so we can see it. So this is the point PQ. T is somewhere here in the middle. Put on in black right here. That's where T is. Let's overwrite this U. That's where T is. Now, if the entire vector up here is U, this is the midpoint. It means that the vector from P to T is half of U. And the vector from T to Q is half of U as well. The other half of U. They divide it half and half of U. Then now I want to show that these 3 points are collinear on a straight line. These 3 points. See them here? Show that they are collinear, we need to find 2 vectors from those 3 points and show that those 2 vectors are parallel. We have 1 vector already because we worked on the MR already. We need another vector with the T. So we know that we have MR already. We're using MR on what? We know MR already. We have it down here already. Just one a while ago. It is this. But we're going to be using this one with the vector separated. 2/3 V plus 1/3 U. 1/3 U plus 2/3 V. Same thing. 1/3 U plus 2/3 V. There's 1/3 U plus V. 1/3 U plus 2/3. I'll write it like that. We're using MR equals 1/3 U plus 2/3 V. We need another vector. I'm using these 2. So either I'm going to use the figure. You will the D. I erased it. Put it back. Right here. Put on it. This is a half of it. So talk to me now, guys. Which vector we're going to use? We need 2 vectors between these 3 points. We're using the vector MR as one of the 2 vectors. Which other vector can we use? Can we use TM, or would you use TM? Or would you use TR? Which one would you use? TM or TR as the second vector?
TR.
TR. Somebody said TR. Why would you use TR instead of TM? Let me hear you. Person who said TR. Why are you using TR instead of TM? I'm not saying anything. Well, let me tell you why you're using TR. Anybody in here, why would you use TR as your second vector rather than TM? Anybody inside here? We do this 3 or 4 or 5 times already. Anybody can tell me? Because it is easier to find TR. Because TR is obviously half U plus V. No calculation needed. That is why. To find TM, you have to calculate. You have to do some calculation to find TM right here. You have to use a half V plus the 1/3 of 2N. More work. It's easier to use the TR because you can see what it is on the graph, on the diagram. Just half U up here plus V out here. No calculation needed for the TR. So the TR will just be half U plus V. These are the 2 vectors we're going to use. So let me copy it down. So this is which 2 vectors we're going to use to show that the points are falling. And they do the business of making them file. These 2 vectors. All right. What the 3 steps method we learn to show that they are parallel. Show that they're parallel first. Collinear points are shown by proving that you have parallel vectors with a common point. We have decided to use these 2 vectors. It's obvious that the R is going to be the common point, but you have to show that they are parallel to complete this proof and get the 3 marks. So that they are parallel, you have to show that one is a multiple of the next. What are the three steps we say? What's the first thing you do when you have these vectors? You want to show that they are parallel. You want to be able to equate them. What do you have to do first? What you have to do first? And don't remember. You have to get rid of any fractions first. Why do we get rid of fractions? Because fractions make it more difficult to see the relationship of the numbers. So get rid of these fractions that are in the numbers. How do we get rid of fractions out of this one? Multiply 2 by a 3 clearly. Right? The lowest common multiple of the denominator value. This time is 3. So you multiply this equation by 3, you get rid of the fractions out of it. Get the fractions out of it. So you multiply this one by 3. You're getting rid of the fractions so that you can see the relationship between these two better. You want to have whole numbers to see those relationships. You see the relationship of numbers better, then they are whole numbers. So that's how we get rid of fractions. You multiply by 3, multiply this by 3, remember to multiply everything by the 3. This becomes 3MR. Multiply this by 3, 3 gone, you get U. Multiply this by 3, 3 again gone, you get 2V. Then to get rid of the fraction out of this one, you're going to multiply by 2. You multiply the second one by 2 to get rid of the fractions out of it. You multiply this one by 2, you get 2TR. Multiply this by 2, you get U. Multiply this by 2, you get 2V. See? Now you have brought them to be equal to the same thing. This and this are the same thing. Now that the two vectors equal the same thing, it means that this expression equals that, because the two of them equal the same thing. That's how we get rid of fraction. If right now they were not the same thing, we'll multiply the small one up to equal the large one. So we can equate. Now that we know that they equal the same thing, we can now equate the two vectors. Now we can equate. That's the next step. You guys don't remember nothing. So we have to revise. We'll remember after this. So we're going to equate this to this, because the two of them equal the same thing. So we can write now that 3MR is equal to 2TR. That's one vector equals a multiple of the other one. That's it. So if we want, we could take this and divide it and here and put 2/3. We don't have to do anymore. So the two conditions that we want for collinearity is in this equation right here. Because of that equation, it means that the two vectors are parallel. That's the first thing you must have a collinear point. Parallel vectors. We have to state these things now. MR is parallel to TR. That's the first thing you must have for collinear points. The second thing you must have for collinear points is a point that is common in two vectors. In this case, it is R. Stated. R is a common point. R is a common point. Because you have parallel vectors, the common point, you can conclude. You can draw the conclusion and say, therefore, the points involved are collinear. Therefore, T, M, and R. Therefore, R, M, and T are collinear. They are collinear. And that is your answer for the last one. All right? You guys need to redo these things if you don't get them. When you go home tonight, redo them after 9 o'clock. More maths equal better maths. End of this test. Hey, we're going. How are you? How much you get you know? Wait now. I want to hear how much I get. What time is it now? It's now 2:40. You start the next one at 3 o'clock? All right, 3:20. We're going to start the next one at 3:20. All right, we'll start the next one at 3:10. Give you guys a break. You're 92. Nice. Nice. Hey, them grades sound good. Come now, come, tell me what you get. Come, let me hear. Remember, there's ones that you got wrong, we do them, please. You got wrong, we do it. Go to full. Work over the 9 marks so you get wrong. Anything you got wrong, you have to redo it. If it's 5 marks to lose, redo the 5 marks. Good, Mr. Mills. You're going good, man. You learn. You're learning. Beautiful. Go and go work over the 19 for me, please. Huh? You want to number 8? Online people, how much you get? How much you get? Jaden, how much you get? 80% is the pass mark today. 80%. 80% is the pass mark today. Go on, how much you get? How much you get? Work over the 18 mark. 18 when you get wrong, write them over, please. We don't know what's coming on the exam. 97. What? What you get? All right, work over the 10% for me, please. Work over anything you got wrong, work them over for me, please. We don't know what's coming on the exam. Grab you. All right, what's this? Huh? Yeah, negative 6. 1 more. Let's go. I'm trying to finish. We go. All right. Different method. You might go the other way. So if you go, you get the same answer, then no good man, all right. Because you could have gone the other way. Yes, could have gone this way. Hold on. But here, it's away from when I use it. Yeah. With the 0, the minimum 1.5. Yeah. With 9. But one go work over the 11 marks, we get wrong, please. Come here, Mr. Brown, where you get? And you, what you get? What you get, Dante? What? Don't work over the 9 marks, we get wrong. Go on, work it over. The 9 marks we get wrong, one go work it over. Get them right. Yeah, soon.
Sir, unfortunately, I got 70%, sir.
Well, who is that?
Read, sir.
Oh, read. 70% nobody read. So we're going to work over the 30% where you get and make sure you improve to tomorrow. Try and improve on the next paper we're going to do today. Right?
All right,
Till
sir.
Mama says 80% of the pass mark. So that's not bad. You see to work a little bit harder. So watch me now. And tomorrow, remember the pass mark is going to be 85 tomorrow. For the 2 people we're doing tomorrow. All right? I think you're going to work it over and don't make mistakes again. Don't make mistakes. That's not bad. Look. No, look over the other. You know the issue is always there. Look over the next question then. Look for the question that we got wrong. Because you don't understand. Look over the question that we got wrong. We'll put up a clock. We're starting. I thought we're starting 3:20, right? 3:20.
3:35, sir.
No, 3:20. We have the whole
Yeah.
day.
So I got 75%.
That sounds good. The 25 that you got wrong, work over the 25% that you got wrong. Over.
Yes, sir.
The videos online, you can rewind and play. The videos on YouTube. That one right now. You can rewind the system and replay the video. I put up a clock. So we're going to 15, 35 minutes from now. But, put up the paper over the minutes. Before the minutes. So people want the paper that I'm doing next, you need to send me a message. I'm send it here. To online. Same thing. What to get, mom? What to get? For the one if you get a good grade on the paper too, on the paper one, and a good grade for the SBA, that good enough. So you're going to 70%. Not bad. $14 marks that. 14. You need 20 marks for that. So get 14 but I think. So we are giving that super multiplier. The multiplier. There's like more multiplier. That's something and this year they are far. Still want to improve. But the 10 people will keep What's the rest out again? T20. Oh, we start later than that. We're going to reach home. We're going to reach home. So we're going to prepare past 9 o'clock. We get to go in the better. That's a fun day. T20. Two people. Starting at 3:20. That's it. Come to me. I know get my people for them. Yeah, I don't go and set up people for them. And then I do other parts of me. Yeah. I'm soon coming to that's 2 was 40 minutes. Right. So you should start now, you know, because you leave early. You Shakeen. Let's stop the recording. Um getting smaller. I don't know why. All right. Stop recording. I want to move. Recording.